Almaty is one of the most polluted cities in Central Asia. According to recent environmental reports, air pollution levels in Almaty frequently exceed World Health Organization recommendations, especially during winter. One of the main contributors to air pollution is traffic congestion.
Every day, thousands of cars create heavy traffic on major roads like Kulzhinsky Tract. Long traffic jams mean more fuel consumption, more emissions, and worse air quality. Many people believe that the solution is very simple, just build more roads. But what if building more roads can actually make this problem worse? Did you know that sometimes building more roads can increase traffic jams instead of reducing it? This phenomenon is called Braess paradox.
Braess paradox states that in some networks, adding extra capacity like a new road can lead to worse overall performance. This happens because drivers act in their self-interest, choosing the road that seems fastest for them. However, when everyone makes the same decision, traffic becomes less efficient for all.
Imagine a simple road network connecting 2 points, an origin, A, and a destination, B. To get from start to finish, drivers have two main choices. They can take the upper route or the lower route, which are divided into a narrow road and a highway. In this initial setup, the travel time on each route depends on the number of cars. To cross the empty narrow road, you will need 20 minutes, and to cross the busy one, 60 minutes. Then, the highway is pretty wide, so it doesn't matter how many cars are going through it, but it is also long, so the overall time for crossing highway will be, let's say, 61 to 66 minutes. The most efficient way to get from A to B, if 6 cars per minute enter roads, is when 3 cars take the upper and 3 take the lower route. In this case, everyone will be driving for 103 minutes. Now, imagine the city decides to help. They build a brand new super fast shortcut connecting the 2 routes. It seems like a great idea. On paper, it gives everyone a third option that looks much faster than the original 2. Naturally, every driver acting in their own self-interest decides to take this new shortcut. Why wouldn't they? It looks like the quickest way to reach the destination. But here is where things get strange. As more and more cars crowd onto this new shortcut, the intersections become congested. Because everyone is trying to use the same fast link, the traffic jams up. Surprisingly, the travel time for every single driver actually increases. Instead of the original 103 minutes, everyone is spending at least 112 minutes on the road now. By adding a road, we have actually made the traffic worse for everyone. This is how Braess paradox works. After learning about this paradox, we asked ourselves, could Braess paradox exist in Almaty?
To find the answer, we decided to use MATSIM, the multi-agent transport simulation model. MATSIM allows us to simulate thousands of individual drivers in a virtual city. Each driver chooses roads based on travel time, and the system shows how traffic patterns change when we modify the road network.
Using MATSIM, we can model different traffic scenarios and test what happens when a new road is removed. And if traffic patterns have changed for the better, this means that in the case of this street, the Braess paradox has worked.
The results of our research can be used in urban planning and transportation policy, because if Braess paradox exists in Almaty's network, it means that making more roads is not always the right solution. Instead, we can use smart planning based on mathematical modeling that really can help reduce the traffic congestion.
Less congestion means lower fuel consumption, fewer emissions, improved air quality, and better public health. In conclusion, our research shows that mathematics and simulation tools can play a key role in creating more sustainable and environmentally friendly cities.